There you go. All right. If you'll go to page, if you don't have your book with you, that's fine. But if you'll go look up here at page 1000, the first thing we learned was that we're going to name them a little bit differently now because they had a systematic name that, at first they thought, hey, this is kind of cute, isopentane, neopentane, one branch, two branches. But then they found out, wait a minute, there's way more than we thought. And so they had to come back with another system. And so what you're learning here is the one you're going to see if you become an organic chemist. So the first thing we learned was we have these things called branches. The good news is if you're a branch that has one carbon, you're a methyl branch, ethyl branch, and then propyl. So let's take a look at propyl. How many ways could you make a branch that has 3 carbons? What would this be called? What would this branch be called? So this is attached to something else, okay? So imagine it's attached to something. Now, the N-propane is the name for a compound, but this is actually a branch, so they don't use N for a branch. So they just call it what? If you look right here, they call it what? They just call it propyl. So it's a propyl branch. But there's another way to make a branch that has 3 carbons. And if you go like this. Now, the book drew it like that, like a T. See how I made like a T? It's more likely to be like a Y, isn't it? So everybody see that? So there's so one of them is called propyl branch, and what's the other one called? Isopropyl. Okay, so there's only 2 propyl branches. How about butyl? How many ways can we make a butyl branch? Okay.
4.
Okay. So what about this branch here? There you go. I can be straighter if you want. So what's that branch called right there? Butyl. Okay. What's another way to make a butyl branch? Look at the second one. It's called sec-butyl. Now, sec-butyl means that see this carbon here. So this carbon here is actually attached to. Just like some of you gave your reports. Who did amines? Do you remember having, when the nitrogen was attached to one carbon, it was called a primary amine, and it had 2 as secondary? Okay, same thing here. This is called a sec-butyl, because this guy here is attached to how many carbons? 2. So there's your sec-butyl here. Now here is isobutyl. Now that one is where, and I think, isobutyl would be, this carbon is now attached to 3, which I think they could have named it something else, but okay, everybody see, wait, did I do that right? Wait, no. 3, 1 branch. 3, 1 branch. Okay, so here they had over here, they had, whoops. Try it again. All right, here's your 3 carbons in a row, but then they put a branch over here. So, everybody see that one? So there's this one has 3 carbons in a row, and this carbon here though is not secondary carbon because it only has 1 carbon coming off it, does it? So it has an iso here. This is isobutyl, and then my favorite one, I don't know why, but my favorite one is called tert-butyl, and and this one, the carbon has attached to 3 different carbons, so that's why it's a tertiary carbon, and that's called tert-butyl. Okay, and that's as far as we're going to go for these kind of branches. We have other branches later on. Do you know a phenol group can be a branch? And they call it phenolic, or phenol, P-H-A-Y-L. All right, so we got that. Now I'm going to show you something else today before we get into whiteboarding. We talked about naming, and if you'll take a look at your homework page, Parker, do me a favor, give me one of those homework pages, please. Thank you. Let's go ahead and do the homework. Now, the homework I do want to turn into a separate sheet of paper. We can write on this, though, for right now. Who wants to volunteer and try to tell me the name of this one? How do we, go ahead, Owen. How do you do this, first of all?
2,2-dimethyl.
Well, tell me how to do it first.
So you want to find the longest straight chain?
And that's the parent chain, right?
Yep.
So 1, 2, 3, 4, 5, 6, 7.
Yep.
How about this way? 1, 2, 3, 4, 5, 6, 7.
That works too.
It does.
So 7, so it's gonna be heptane. And you know that you wanna count from the shortest end, and you got 2 methyl groups on the same carbon, so you're gonna have the same number. So it's 1, 2, so then it's 2, 2 dimethyl, since there's 2 methyl groups. Heptane, because there's 7.
Right, so we have two methyl branches, so it's dimethyl, and they happen to be in the same place, and I have to tell you that, don't I? Because is there another way to make a dimethyl heptane? I could put one here and here, couldn't I? Hey, can you ever put a branch here, though? If I put one of these here, then don't I have actually octane? Okay, so you can't put a branch at a 1, you can't put a branch on the last one either, so. All right, next one, who wants to do the next one? McKinley, I bet you can do this one. What's the longest straight chain I can get on this one?
7.
Okay, so let's go this way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Whoa. 1, 2, 3, 4, 5, 6, 7, 8. So what is it?
Octane.
Now, what I'm going to do is, this is something that helps me by circling the parent chain. Then I know the other ones are branches, aren't they? All right. What kind of branches do you have?
There's a methyl group and an ethyl group.
All right.
So it would be 3 methyl and 4.
Okay, so if you go this way, it'd be 3. 1, 2, 3, 4, 5. So it'd be 3, 5. The 2 branches.
So you count.
What if you go the other way?
4.
4. 1, 2, 3, 4.
No, the other one.
Oh, the other way. 1, 2, 3. I'm sorry, 4. That'd be 4, 6, wouldn't it? So which one's the smallest set of numbers?
3, 5.
So smallest set of numbers would be 3, 5, wouldn't it? Okay, now they have this thing about alphabetical order, but they don't count things like di and tri. So which one would come first then?
Ethyl.
Okay, so where's your ethyl at?
5.
5 ethyl?
3 ethyl.
Yes. Anyway, what do you think about that? Pretty good? All right, and let's do the next one. Let's do that one. Parker, you want to do that?
I'm good.
What's the longest parent chain?
For me?
Yeah.
There is no choice.
I guess not. I can't count. 1, 2, 3, 4, 5. I'm guessing 6.
Okay, so
5.
we're,
Are you counting the?
so the longest parent chain is 6, you said?
Uh,
1, 2, 3. No. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. What's the longest chain?
there's not a line there.
Oh.
I was combining it with.
Oh, you're combined with this one. Ah.
I guess.
Rookie mistake.
So what's your longest parent chain?
3.
How many?
3.
How many?
3.
How many? Let's try it again.
Plus
1, 2, 3.
Keeps saying 3.
1, 2, 3, 4.
From the
1,
very
2,
bottom to the
3,
top
4.
one of them.
Okay, so what is it?
4.
So what's the last thing out of your mouth?
Propane.
No, don't do
There's
that.
4, so there's propane.
Don't do that. Prop means 3 carbons.
I'm too tired for this. Meth, proputane.
Okay. Okay, so now what I do is I actually go ahead and circle the parent chain, then that leaves the rest of them branches, right?
Yeah.
So what kind of branches do you have?
2 or 3 of them. 3 ethyls. Or I mean methyls.
Okay, 3 methyls, so how would you say that?
3 methyl.
Yeah,
Trimethyl.
okay.
Attaboy.
Now, is that the only way you could make trimethylbutane?
there's multiple ways. There's multiple.
So if there's more than one way, you do have to give me the numbers. So, and you asked that question yesterday. I would go ahead and give the numbers anyway. Get that?
What's the other way?
Okay, so here on the second carbon, we have a branch. And on this if I go this way, the second carbon has 2 branches, right? So I could put 2 branches on the second carbon going this way, 2, 2, 3. What if I go the other way? What if I put 2 branches on this one? It'd be 2, 2, 3, wouldn't it? So is there any other one? What do you think? Is there another way to put these 3 branches?
No.
And you can't have a branch here, and you can't have a branch here. So even if I put another branch here, I have this branch. What if I put another methyl here? Then I only have one more methyl to go, right? And so I'd have to put it here. So it's either going to be 2, 2, 3 or 2, 2, 3. So what do you think?
2, 2, 3.
Now again, I'm going to put that in parentheses because there is that's the only way you could actually make that one like that. All right, this is a tough one. The hardest one. Who wants to do the hardest one?
Mason.
I think you could volunteer someone here, volunteer.
Let's see, Clayton. He looks like he wants to do that.
Oh, yes.
Clayton, what do you think here? This is a little bit harder. This is actually by far, way harder than the other ones.
You're so much better than us.
Oh, gosh. You sound.
And I'm okay. I'm okay if you make any mistakes. It doesn't matter to me. But what do you think?
So, is that a pentane? Or-
Yeah, sort of. It's a type of pentane,
Okay,
but it's a ring structure.
right, so, cyclopentane,
Yes.
okay.
So there's my parent chain. That's
Oh, and then you
cyclopentane.
have
Ooh, now what? This one.
That is a,
Ooh, look. He's looking on page 1000.
is that a terbutyl?
Yes. Wow. I didn't think anybody'd get that. This branch is a butyl branch, but it's a tert-butyl, isn't it? Tertiary butyl branch. So tert-butyl cyclopentane. Woo.
Was that it?
That's it. What do you think? That was a hard one. Okay, now let's try have you make one. Instead of you looking at it and naming it, let's see if you can draw one. Everybody try this one. Draw 1 ethyl, 3 propyl, cyclohexane.
I thought it could never be on one.
What now? Well, that's a good question. In a straight chain, you would never have a branch at 1, but with a ring structure, yeah, you would. That's a good observation, Owen. A little bit different when you have to draw it.
That looks better.
All right. Everybody ready? All right, Marie, coming up, bring your paper up. Let you draw for everybody. Again, today, we just got started with this chapter, so I'm not worried about making mistakes or anything like that. We're going to learn from any kind of mistakes. Don't act like you have to be perfect.
Okay, so it's cyclohexane, which means it's a ring structure and it has 6 carbons. And then I just randomly assigned the one because I don't know how you assign that. And I did an ethyl group. And then I counted 1, 2, 3 and did a propyl group.
Wow, I didn't expect that. That's great. That's it. So here, in this case, thank you. Owen had a good observation. I thought you didn't have branches at 1. You wouldn't on a straight chain, but you're right here. Once I have this one, here's cyclohexane, and these are all single bonds, right? Because it says hexane. And here's what happens. Ethyl is going to be at the number 1 carbon. So I hereby declare, there we go, I hereby declare you must be carbon number 1 right there. And if that's carbon number 1, you can go either way. You can go clockwise or counterclockwise. If that's 1, then this has to be 2, and this has to be 3. And excellent. Good job. What do you think about that? It's kind of neat, isn't it, how they name this? All right, let's try the next one. One more, and then we'll do something else. Look at it, and There's only two of you haven't answered a question yet, so I'm gonna call on one of you. So, you ready?
Yeah.
Now, come on up. All right, you're going, and you're gonna do this one. 1,1,1,1,2 trichloroethane. That right there. And here, good observation again. Even though we're not putting a carbon as a branch, we're now using a halogen, aren't we? A chlorine, fluorine type kind of thing, and then we can number them 1. Okay. All right. Go ahead.
Well, I just did an ethane, which is a C and a C, because it's 2. Then I put 2 chlorines on the first one and 1 on the second one.
Okay. And are there any other elements there anymore? I knew you do the carbons and the chlorines. Are there any hydrogens in there also?
I mean, there should be 2 right there and 1 right there, but I didn't think you had to
That's
write
right.
those.
You're right.
They did
All
that.
right. Everybody got that? So in this case, we saw 2 in a row where they actually used the number 1, but it wasn't a, one of them was because they had a ring structure, and one of them was because we had something, not a carbon. I can't have a carbon branch be at number 1. But in here case, let's say 1, so chloro and 1,1,2, 1,1,2, and then of course there'd be hydrogen here. 1, 2, 3, 4, 1, 2, 3, 4, like that. Very good. What do you think? All right. A couple more things, then we'll get the whiteboards out. Let's go, if you don't have your books, that's fine, but take a look on this page, 1003. Now, even though when I was in college, I didn't necessarily enjoy organic chemistry. I didn't have the basis idea. I never even heard the word organic chemistry as far as that, but a lot of it was something like this, which some people really like, and I didn't. This is called mechanisms. And this is how a lot of the products that you have, some of the clothes you're wearing, some of the materials you have, your cell phone material, some of these were made by organic chemists, and they had to learn how to manipulate atoms. Say, I want 2 chlorines here. Or no, I want a chlorine, then a hydrogen, then a chlorine. And they had to learn how to do these mechanisms. And so take a look at this right here. It says here, this is called a substitution reaction. Here we have methane, and you add chlorine to it, and then they use UV light. They use ultraviolet light, and for some reason, that breaks the hydrogens off and allows the chlorines to come on, at least 1 chlorine. So 1 chlorine was attached to it, and it's called chloromethane. Then they did it again, and what happened? What's this right here? Dichloromethane. Then they did it again, trichloromethane, and then the last one is tetrachloromethane. So that's how they, this is kind of a mechanism here like there. So when you see a little HV, HV has to do with a certain frequency of light. In this case, I think it was ultraviolet. And so a fancy name for this, if you want to do the same thing with bromine, you could do that. If you want to do it with iodine, you could do that. Or fluorine, you could do that. And so if you did that with any of the halogens, you would call that halogenation. So this right here is how you halogenate different hydrocarbons. All right, does that sound good? One of the things down here they talked about is, I probably don't remember 10th grade, but one of the articles they talked about CFCs, chlorofluorocarbons. And for a long time, over 50, 60, 70 years, people used things like Freon, and they were chlorofluorocarbons to do air conditioning units, refrigerators, freezers. And then at one time, somebody did some work, and they said, hey, do you know that these CFCs, when you throw a refrigerator in a dump, the CFCs eventually escape. If they get it in the upper atmosphere, they destroy the ozone layer, and we're all about the Earth, and so we don't want to do that. And so they said, we're going to try to ban CFCs. Well, of course, you're telling the entire world that everything that air conditions every building in the world, and every car, and every refrigerator, you can't do that overnight. So they said, we'll give them 10 years. Of course, they gave the chemical corporation 10 years to find another refrigerant that would take its place, and they have fancy, not so fancy names like R15. They have some new names for some of those. If somebody want to do a little article on that, what are the new refrigerants? What refrigerants are used now that they're not used? So if you think about that, you want to do a little extra credit report, you could do that. Okay, show you one more thing, and then I may be running short on time today. All right, what if I did something like this? What if I took a, what's the name of this right here? Everybody should know this real quickly. Ethane. If I took ethane and somebody figured out that if you put, what is that, chromium, oops, I can't read that very well. Chromium 3 oxide, okay. I don't know who discovered that, but somebody said you can use a catalyst, chromium 3 oxide, and 500 degrees Celsius. I don't know who did that. Somebody discovered if you take ethane and put it through chromium 3 oxide at 500 degrees, why would you do that? And look what happened. What happened to it? Ethane turned into what? What's this? Rollins, what's this? Ethene, also known as ethylene, right? So if you want to take a single bond and change it into a double bond, somebody figured out how to do that. And it also gave off hydrogen. So what would be a fancy name for this process? And there it is. What would this be called? See if you can say that. You're going to sound like really smart if you go home tonight. Hey, what did you do in chemistry? Well, we talked about different isomers and halogenation. And what's this one? Can anybody say that word? Dehydrogenation. Dehydrogenation. You talk that, you know, and your parents, maybe like chemists, dehydrogenation. So we could actually do that. And what if we did the opposite? What if we had something at a double bond and we wanted to get rid of the double bonds? What would you call that? Hydrogenation. Wow. Now you're thinking like chemist. All right. So what I want to do here is we have a little bit of time here, and I instead of getting the whiteboards out, I'm going to save just a little bit of time. Take your just take your packet. I don't have a white here. Take your packet. Let's go on the back here. And tomorrow I'll do a lot more whiteboarding. I thought I was going to get the whiteboards out, but I'm going to be short on time. Ready? Let's draw and name all the isomers of this. Draw and name all the isomers of this.
Done.
Okay, thanks. All right, we're done. And what's the name?
Math.
We can't see what you're.
Oh, I magnified, didn't I?
Just thought I'd articulate.
Okay, now, so we're done with all the one carbon alkanes. Draw and name all of the isomers of not methane, but ethane. Okay, and so, are you ready? We just do carbon backbones. How about that? Want to do that? You okay on that? Is there another way? Okay, so how many isomers of methane are there? 1. How many isomers of ethane are there? 1. Let's do propane. How many isomers of propane?
2.
2, okay. Name them.
Isopropane and propane.
Okay, how do you draw isopropane?
The branch is just in the middle
Okay, so how do I have a middle branch?
by just drawing a line down
From what?
the carbon.
Here, right, down here?
Yeah,
Like this?
and then no,
No, you don't like that?
Up,
they're just like
You don't here?
wait, up,
Here? Here?
side,
Here? Here?
left.
no. You gotta do a loop.
Oh, what now?
A
Cycle.
loop.
Oh. What about that?
That works.
That work?
That works.
What's the formula of this guy?
And propane, probably.
What's the formula of this one?
C3H8.
What's
We're
this one?
just doing the carbon backbone.
1, 2, 3,
That's how my lead right now.
3, 4, 5, 6. Ooh.
It's close enough.
So in this case, a ring structure, though, remember you pay a price for a ring structure, you lose 2 hydrogens. So there is only one isomer of propane. Here we go. Butane. All right, butane, go. All right, draw and name all the isomers of butane.
I don't see you drawing harder.
Mentally, I'm still
You're
not,
mentally
so.
absent.
My binder's gonna take
And remember, I didn't have to say N propane here because there is no other isomer. I didn't have to tell you which one it is. There's only one. But here I do have to tell you that this is N butane. Are there any others?
Yes, a T.
And I'll show you a little trick on how this works, okay? We're gonna work our way up even to octane, okay? So let me show you a little trick. If you've exhausted all the ones that are 4 in a row, then what's your next choice?
3 in a row.
3 in a row. Now, you can't put a carbon branch here, and you can't put a carbon branch here, so let's put it here. All right, what do you think? Now, let's name this the real way to name it. Here's my parent chain. What words comes out of my mouth here? Propane. And do I have a branch?
2-methylpropane.
You can, and, right, and we wouldn't have to say 2 because there's no other way to make methylpropane. Are we okay on that? Is there another isomer? Okay, so there are 2 isomers of butane. Let's go ahead. Let's go to pentane. And again, the same trick applies. I think I've exhausted all the ones that are 5 in a row, so now I had to go do 4 in a row. Okay, so what do you think about that? Where am I going to put that branch? I can't put it here, and I can't put it here. What if I put it here? Would that work? Sure. But could I put it here instead? Look up here. Could I put this branch here and make a new one? No, it's the same one, isn't it? Can I put it up here?
Yes.
No, it's the same one. Can I put it up here?
Yes.
No. So what do you think? So what do you think? Now, after you've exhausted all the ones that are 4 in a row, now what do you do? 3 in a row.
Oh.
And now I still have 2 more carbons, and there's only one other way I could do that. All right, let's name it N-pentane. What's the name of this one? Here's my parent chain. Say it again. 2, or in parentheses, methyl butane. All right, how about this one? What's the longest parent chain?
Propane.
3. So what do you say at the end? Propane. Have you answered one yet? I'm sorry. Go ahead. Can you give me this one?
Wait a minute.
Don't think she asked.
It's
See, I didn't. But-
Okay, and I can put that in parentheses. 2 what? Yes.
Because you don't need to say.
Oh, cause there's.
Okay, so here's a methyl branch, and here's a methyl branch, dimethyl, and 2. There's only one way to make this. All right.
Whoa! Don't throw that one yet.
Oh, I got some space here.
There's another.
Okay, go ahead.
It's 3 C's across the top.
3 in a row.
Yep, and then 2 branching off the middle one.
Okay.
I was thinking about
No,
that,
but
but
that's
I was
the
like,
same one
he
right
didn't
there.
write that, so.
Okay,
Yes,
now,
we did that.
what's interesting, and when we started doing whiteboarding,
That would be 2-dimethylbutane.
it's interesting, take a look, is you now have made a parent chain that is actually butane, and this would be 2-methylbutane,
That one's better though.
perhaps. But anyway, but I like the fact you were thinking about it. But after you start naming it, you'll say, wait, if I had to name that, it would be 2-methylbutane, and I already did that before.
Oh, and as you can see, I made a similar mistake and already erased it.
But that's what we're doing, and as we work our way up all the way to octane, you're going to have to do that with your group. You're going to say, hey, here's something different. Here's something different. We'll name it. And if you have the same name, you'll say, oh no, it's not a different isomer. It's just a different conformation. Maybe just twist it a little bit. All right, what do you think? All right, now.
Hexane.
All right, you ready?
You know what, we do.
We'll do this. We'll start to. Right, so 1, 2, 3. There are only 3 isomers of pentane. Now, let's go with hexane. We'll probably, I don't know if we'll get these done today, so we may do this tomorrow, but let's do everybody knows how to do the first one.
Well,
Well,
maybe not perfect.
maybe not me
N-hexane.
or Jeffrey. Well, I'm not.
Okay, so challenge yourself. We have another 3 or 4 minutes. Go ahead, and we can't do any 6 in a row, so I wonder how many 5 in a rows can we do? So maybe we'll just try 1, 2, 3, 5, and I have to put a branch. Let's see, I can't put a branch here. I cannot put a branch here. I could put one here.
I made a cross.
And I wonder if that's the only place I could have put that branch. Have I exhausted all the 5 in a rows yet?
Wait, did you also make a
Well, I
cross?
can't see it.
No shot.
No shot.
Okay, see that? So, now, look up here just for a second. Do you understand that this branch here would be the same as going up here, isn't it? And this branch here is also the same as going here, it's just backwards. So is there one other way I could do that? And it'd be right here, wouldn't it? Everybody there?
Yep.
Now, have we exhausted all the 5 in a rows?
Yep.
You sure?
Yep.
Yeah.
Okay, let's go ahead and name this. What's this one?
2-methylpentane.
Say it again.
2-methylpentane.
Oh wait, we're not doing that.
And you did have to tell me where that was. So you did, that's right, 2-methylpentane. And what about this one? You guys are getting good at this. Okay, so now if you've exhausted all the 5 in a row, are you sure?
Yeah.
Are you sure?
Yep.
Are you sure?
Yep.
Okay, so let's go with 4 in a row.
By my count, there should
I got 2 more.
be 3, 4.
You got 2 more. 2 more branches. I mean, 2 more carbons.
Get one down.
So what do you think?
That's all you need.
What do you think? You want to do a methyl somewhere?
Yeah.
Okay, let's do a methyl somewhere. There's that one.
How about 1 on 1, 1 on 2?
Ooh, I like this. So not number 2 carbon. Can we put 1 here and 1 here?
Oh, that's what I did. I did that one.
No way.
Could I put 1 here and 1 here?
Oh,
No shot.
yeah.
Okay. Are you sure it's different?
Yeah.
Yes.
Well,
Could I put 1 here and 1 here?
Oh, we can't see it.
so I'm assuming yes.
Can I put 1 here and here?
No.
No.
'Cause
No.
that's the same.
Single bonds can actually rotate. So what would happen is by putting here and here, that'd be the same as here and here, wouldn't it? Is there any other? Can I put another one or not? Well, I know.
You could do
I know.
this.
How about 1 here and 1 here?
Oh,
It's the same.
That's the same as
see,
this.
that's
We could do 1 on each.
What now?
Can you do 1 on each?
Each one.
the end.
Yeah, but if it's on
I
the
can't
other
put
side-
branches on the end. I can't put carbon
No, I
branches.
know, but could you do 1 on that one?
This one?
Going down, and
Okay.
then the other one going up?
It's the same.
Going up?
You can twist
Like this one?
No.
This one?
Yeah, but go up.
Okay.
No, the way.
Okay. That now what
No,
happened is
name that one.
it could twist and it'd be the same as this one though. But look what
I
happened.
hate
Oh,
twisting.
what about this one though? Is that it? Wait, is that it?
No, that's.
Or look what
Wait a
happens
minute.
when I start putting an ethyl branch on something that's not too big anyway. What happens?
It's just the that looks like.
Ooh, that looks like what?
That
That looks like 3-methyl. That looks like what?
Pentane.
3-methylpentane. So I can't do that. Okay. Any others? Any others with 4 in a row?
Nah.
All right. Let's do. And about 3 in a row. Ooh, how about 3 in a row?
That's a good question.
Now you got 3 more carbons to put somewhere.
Where are you gonna put that?
It's a big question.
What do you think?
Tell me.
1,
Answer that.
McKinsey.
2,
McKinsey.
3. Ooh, look at that one. Look at that one. What do you think?
No, that's the same.
No.
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 That's the same as what? Dimethylbutane. So what is this one? This one actually is dimethylbutane.
Oh, that's what I did. Wait, with Two
And by the way, I'll go ahead and put 2,2, even though,
That's my first
and what's the
one I
name,
got
what's the
right.
name of this one here? This is also dimethyl butane,
That's too.
and that is 2,3. Okay, so I do have to put 2,2 here, and I do have to put 2,3 because they're, what do you think? How many are there? 1, 2, 3, 4, 5. You're out.
Is that the countdown till 4?
5.
Yes. Okay, thanks. On your homework, you can start on this, and please put that on a separate piece of paper. It makes it a lot easier for me to grade. And I took off a lot of questions. You don't have as many as normal. And I might come back later with the multiple choice part. Just hand it to you one day, let you work on it as a group or something. But I took the multiple choice. No, I took some of the multiple choice off. Yes.
Do you know when the test is gonna be?
Tomorrow.
We have a little while. It'd be next week. I'm trying to think. Next week we start the new schedule. So here's my problem. I've got to figure out the new schedule.
I want Bible
And
on 7,
so this class,
Dude, it's barely home. It's so sad.
I might have a quiz this Friday. This Friday I might have a quiz, but a test. I don't know if that would happen until
I just don't want your
next Wednesday. The 90-minute period. That would work, but we'll see. I'll have to look because with the new schedule, I got to figure this out. It's nice for me to have 90 minutes for a test, but
Yeah, but can
Wait, so in the new schedule, is there just gonna be like a week where it's gonna be all of our tests? Like, I think that's what it's gonna be.
They're
Like,
not, okay.
all the 90
Oh,
minutes.
yeah.
That's gonna suck.
no, I think your humanities teachers are going to use the 90 periods for like debates and stuff.
Thank you, Mr. Bean.
All right, bye.
Mr. Bean, so I did all of my test corrections last year. I forgot them at home though. I was just took all my stuff.
I'm okay. I'm okay.
So you don't expect that, but there was one I didn't know.
I'll help you.
Know that one?
I'll help you. And if you don't, just remind me tomorrow, Rollins. Say I'm going to do my report first thing.
Okay.
And
Oh, I thought you were asking.